Hello everyone and welcome to another math video. I'm Professor Diwa. In this video, I'll be going over formulas and problem solving. Our objectives are to solve a formula for a specified variable and use formulas to solve problems. Alright, so let's get started. First, let's talk about formulas. Here it states that a formula is an equation that describes a known relationship among measured phenomena, such as time, area, and gravity. Below we have a few examples of formulas and their meanings. Our first formula is capital I equals capital P times lowercase r times lowercase t. This formula is used for calculating interest. So I represents interest, P represents the principal, r is the interest rate, and t is time. Our next formula is capital A equals lowercase l times lowercase w. This formula is used for calculating the area of a rectangle. A is the area of the rectangle, L is the length, and W is the width. Our next formula is lowercase d equals lowercase r times lowercase t. This formula is used for calculating distance. D is distance, r is the rate, and t is the time. Our next formula is capital C equals 2 times pi times lowercase r. This formula is used for calculating the circumference of a circle, where c is the circumference and then r is the radius of the circle. Our last formula is capital V equals lowercase l times lowercase w times lowercase h. This formula is used for calculating the volume of a rectangular solid, where V is the volume, L is the length, W is the width, and H is the height. Next, we'll go over the steps for solving an equation for a specified variable. Step number 1, clear the equation of fractions or decimals by multiplying each side of the equation by an appropriate non-zero number. Step number 2, use the distributive property to remove grouping symbols such as parentheses. Step number 3, combine like terms on each side of the equation. Step number 4, use the addition property of equality to rewrite the equation as an equivalent equation with terms containing the specified variable on one side and all the other terms on the other side. Step number 5, use the distributive property and the multiplication property of equality to get the specified variable alone. Alright, so in the next set of examples, we're going to be using these steps to solve for a specified variable. In example number 1, it states, solve for each of the following equations for the given variable. For part A, we have capital I equals capital P times lowercase r times lowercase t. They want us to solve for lowercase t for this problem. So the first step would be to get rid of any fractions or decimals, but we don't have any fractions or decimals in this equation. So we go directly to step number 2. Now for step number 2, we don't have any grouping symbols such as parentheses. So we skip to step number 3, which is combining like terms. However, there are no like terms, so we move on to step number 4 using the addition property of equality. However, there is no addition or subtraction in this problem, so we go directly to step number 5. For step number 5, we use the multiplication property of equality to get rid of the p and the r so that we could isolate t all by itself. Since the p and the r are multiplying the t, we need to divide both sides by p and r. When we do the division, we get I divided by PR equals PRT divided by PR. Simplifying the left-hand side, we get I divided by PR will stay the same, equals, and on the right-hand side, the P and the R will cancel out with the P and the R on the denominator, leaving us with just T. So we have I divided by PR equals T. We can also write this as T equals I divided by PR, which is our final answer. Moving on to part B, we have 3y minus 2x equals 7, and we need to solve for y. For this problem, we could skip the first step, which is clearing out any fractions or decimals. We could skip the second step, which is getting rid of any grouping symbols. We could skip the third step, which is combining like terms. And we could go directly to step number 4, which is using the addition property of equality. I want to isolate the 3y, So I'm going to get rid of the minus 2x by adding 2x to both sides of the equation. Simplifying the left-hand side, we have minus 2x plus 2x cancels out, and we could bring down the 3y. We have equals, and then on the right-hand side, we could also bring down the 7 and the plus 2x. So we have 3y equals 7 plus 2x. Next, we need to get rid of the 3 in front of the y. We do this by just dividing both sides by 3. So we have 3y divided by 3 equals 7 plus 2x, all divided by 3. Simplifying the left-hand side, 3y divided by 3 is just y, equals, and then the right-hand side, 7 plus 2x divided by 3 will stay the same. So our final answer is y equals 7 plus 2x, all divided by 3. Now another way we could have written our answer is y equals 7 divided by 3 plus 2x divided by 3. Next, we have a practice problem. It states, solve each of the following equations for the given variable. For part A, we have the equation v equals L times W times H, and we need to solve for the variable H. For part B, we have 2y plus 5x equals 10, and we need to solve for x. Alright, so go ahead and pause the video, try out these practice problems, and then check back with the video to see how you did. Okay, so let's get started. For part A, we need to solve for h. First thing we need to do here is get rid of the L and W by dividing out L and W on both sides of the equation. When we do the division, we get V divided by LW equals LWH divided by LW. Simplifying the left-hand side, we have V divided by LW will stay the same. We bring down the equal sign, and on the right-hand side, the LW on the numerator will cancel out with the LW on the denominator, leaving us with just an H. So we have V divided by LW equals H. Now our final answer, we could leave it in this format, or you could rewrite it as H equals V divided by LW. For part B, we need to solve for x. So first I need to get rid of this 2y by subtracting 2y from both sides of the equation. Simplifying the left-hand side, the 2y minus 2y will cancel out. We bring down the plus 5, we bring down the equal sign, and on the right-hand side, we have 10 minus 2y. Next, we need to get rid of the 5 in front of the x by dividing both sides by 5. So we have 5x divided by 5 equals 10 minus 2y, all divided by 5. Simplifying further, we get 5x divided by 5 is x. We have the equal sign, and then on the right-hand side, we leave everything the same. We have 10 minus 2y, all divided by 5. Now another way we could write our final answer is x equals 2 minus 2y divided by 5. In example number 2, we have the equation capital A equals 1/2 times the parentheses capital B plus lowercase b close parentheses times h. For this equation, we need to solve for lowercase b. So the first step here would be getting rid of the 1/2 and the h. Since the 1/2 and the h are both multiplying everything in the parentheses, we need to do the opposite of multiplication, which is division. So we divide both sides of the equation by 1/2 and h. When we do the division, we get a divided by 1/2 h equals 1/2 times the parentheses capital B plus lowercase b close parentheses times h, and everything on the right-hand side is divided by 1/2 h. Simplifying the left-hand side, capital A divided by 1/2 h will become 2 capital A divided by h equals, and then on the right-hand side, the 1/2 and the h on the numerator will cancel out with the 1/2 and the h on the denominator, which gives us capital B plus lowercase b. So the result should be 2 capital A divided by h equals capital B plus lowercase b. The next step is to get rid of the capital B by subtracting capital B from both sides of the equation. On the left-hand side, we get 2 capital A divided by H minus capital B equals, and on the right-hand side, we have capital B minus capital B will cancel out, and we just bring down the B. So our final result is 2 capital A divided by H minus capital B equals lowercase b. Or we could flip it around and write it as lowercase b equals 2 capital A divided by H minus capital B. Next, we have another practice problem. The equation is capital A equals capital P plus capital P times lowercase r times lowercase t. For this equation, you need to solve for lowercase r. So go ahead and pause the video, try out this problem, and then check back with the video to see the answer. Okay, so let's go over the solutions. So the first step for solving for r is getting rid of capital P. So what I did first was subtract capital P from both sides of the equation. On the left-hand side, we get capital A minus capital P equals, on the right-hand side, we have capital P minus capital P will cancel out, and then we just bring down the capital P times lowercase r times lowercase t. Next, we need to get rid of the capital P and the lowercase t. We do that just by dividing both sides by capital P lowercase t. We have capital A minus capital P divided by capital P times lowercase t equals capital P times lowercase r times lowercase t divided by capital P times lowercase t. On the left-hand side, there isn't anything we can actually do, so we leave it exactly the same. On the right-hand side, the capital P's and the lowercase t's will cancel out, leaving us with lowercase r. So our final result is capital A minus capital P divided by capital P times lowercase t equals lowercase r. Or we could flip it around as lowercase r equals capital A minus capital P divided by capital P times lowercase t. Next, we're going to go over the compound interest formula. The formula is capital A equals capital P times the parentheses 1 plus the fraction r divided by n, close parentheses, raised to the exponent of n times t. A represents the amount of money in an account after t years. The P represents the principal or amount invested. T represents the time in years. R is the annual interest rate given as a percent. And N represents the number of times compounded per year. This could be twice a year, once a year, 6 times a year, and so on. Next, we'll go over an example using the compound interest formula. In example number 3, use the compound interest formula to solve the problem. Ken received an inheritance of $10,000 and plans to place all the money in a savings account that pays 5% compounded quarterly. How much money will be in the account in 3 years? To solve this problem, we just use the compound interest formula, which is capital A equals capital P times the parentheses 1 plus the fraction r divided by n, close parentheses, raised to the exponent of n times t power. From here, we just plug in all of the values in for each variable. For capital P, this represents the amount invested, which is $10,000. For R, this is the annual interest rate, which is 5%. However, we plug in the value of 0.05 to represent 5%. For N, this represents the number of compoundings per year. The problem states that it's compounded quarterly, so this is 4 times per year. For T, this is the amount of time the money is invested in the account, so this would be 3 years. Now we could go ahead and substitute in all of the values. We get 10,000 times the parentheses 1 plus the fraction 0.05 divided by 4, close parentheses, raised to the exponent of 4 times 3 power. From here, you can plug everything into a calculator. However, I would recommend doing everything in parts and make sure you follow order of operation. So the first thing we would do is everything inside the parentheses. We have 1 plus 0.05 divided by 4. Plug that into a calculator and we get 1.0125. The next step is taking that value and then raising it to the exponent of 12. After you raise it to the exponent of 12, then you multiply it by the 10,000. Our final result will be 11,607.54518, and that decimal actually keeps on going. Now, when we're working with money, typically what you want to do is round to the nearest cent. So for our final answer, I wrote out a short sentence which states there will be $11,607.55 in the account in 3 years. Next, we have a practice problem. Use the compound interest formula to solve the following problem. Russ plans to invest $8,000 in a savings account that pays 6% compounded semi-annually. How much money will be in the account in 4 years? All right, so go ahead and pause the video, try out this problem, and then check back with the video to see if you got it correct. Okay, so let's go over the solutions. We just used the compound interest formula. For P, I plugged in 8,000. For R, I plugged in 0.06. For N, I plugged in 2. And then for T, I plugged in 4. So I have 8,000 times the parentheses, 1 plus 0.06 divided by 2, close parentheses, raised to the exponent of 2 times 4. Simplifying the inside of the parentheses, I get 1.03, bring down the 8,000, and then I have the exponent of 8 on the 1.03. Plugging this into a calculator, I get 10,134.16065, and the decimal keeps on going. Rounding this value to the nearest cent, I get that there will be $10,134.16 in the account in 4 years. Next, we have example number 4. Use the distance formula to solve the problem. If a biker traveled 3,107.5 miles at a speed of 15.4 miles per hour, how long was his cycling time? Write the time in days, hours, and minutes. Round to the nearest minute. So for this problem, we'll need to use the distance formula, which is distance equals rate times time, or d equals rt. Okay, so in this problem, our distance d is 3,107.5 miles. Our rate r will be 15.4 miles per hour. For t, this is what we're trying to find. So now let's go ahead and plug everything in. We get 3,107.5 equals 15.4 times t. We want to solve for t, so we just divide out 15.4 on both sides of the equation. We get 3,107.5 divided by 15.4 equals 15.4t divided by 15.4. Simplifying the right-hand side, the 15.4 will cancel out with the 15.4 on the denominator, leaving us with just a t. So we get t is equal to the fraction 3,107.5 divided by 15.4 hours. So I decided to leave t in terms of a fraction to make our answer more precise. According to the problem, our answer needs to be in a specific format, which is in days, hours, and minutes. Right now our answer is in hours, so we need to convert it into days first. To do this, we just multiply by the unit fraction 1 divided by 24. This represents the number of hours in a day. So we have in one day, there's 24 hours. And on the unit fraction, the units you want to convert to is on top, and the units you want to get rid of is on the bottom. So we have days on top and then hours on bottom. Now we could go ahead and multiply. So we have 3,107.5 divided by 15.4 times 1 over 24 equals 8.407738, and this decimal keeps on going. Okay, so this decimal tells me that there are 8 full days and then we have 0.407738 of a day. Next, we'll need to convert the 0.407738 of a day into hours. To do this, we will just need to multiply by the unit fraction 24 over 1. So remember that the unit you want to keep goes on the numerator, and the unit you want to get rid of goes on the denominator. So we have 24 hours over 1 day. Also, when we do the multiplication, make sure you use the full decimal value that shows up on your calculator. On the video here, you can see I just have 0.407738, but notice the 3 dots after. This means that the decimal value keeps on going. For instance, on my calculator, I have 0.4077380952. So I'm going to use that full value for my calculation. When we do the multiplication, we get 0.407738 ... Remember, use the full value on your calculator, times 24 over 1 equals 9.785714 ... So again, that value keeps on going. So the units we get are in hours. So this means that we have 9 full hours, and then we also have 0.785714 of an hour. So for part of our final answer, we already have 8 days, and then we also have 9 hours. The last part is finding out the minutes. So we'll take this last portion here, the 0.785714 hours, and convert that into minutes. To convert this into minutes, we just multiply by 60 over 1, or 60 minutes over 1 hour. So when we do the multiplication, we have 0.785714 ... Again, remember to use the full value on your calculator, times 60 over 1 equals 47.14285 ... Again, this decimal value keeps on going. So the units we have are in minutes, and the problem told us that we want to round to the nearest minute. So this would be 47 minutes. So our final answer would be that the biker's cycling time is 8 days, 9 hours, and 47 minutes. Next, we have another practice problem. It states here to use the distance formula to solve the problem. If a biker traveled 192 miles at the speed of 7.5 miles per hour, how long was his cycling time? Write the time in days, hours, and minutes. Round to the nearest minute. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see how you did. Okay, so let's go over the solutions. For this problem, we use the distance formula d equals RT, and we're solving for t. For d, we plug in 192, and for r, we plug in 7.5. We get the equation 192 equals 7.5t. To solve for t, we just divide both sides by 7.5. So we get 192 divided by 7.5 equals 7.5t divided by 7.5. Simplifying the right-hand side, we have that 7.5t divided by 7.5 cancels out and leaves us with the t. So we get t equals 192 divided by 7.5 hours. Simplifying this further, 192 divided by 7.5 is 25.6 hours. So what we need to do now is convert 25.6 hours into days. So we take our 25.6 hours and we multiply it by the unit fraction 1 day over 24 hours. When we do the multiplication, we just take 25.6 times 1 over 24, and we get that this is equal to 1.0666666 repeating, and the units is days. So from here, we know that we have 1 day as part of our answer, and then we need to take the 0.0666 repeating and convert that into hours. So we go ahead and use the full decimal value in your calculator. So again, 0.0666 repeating. We multiply that by the unit fraction 24 hours over 1 day. So we go ahead and multiply 0.0666 repeating times 24 over 1. We get 1.6 hours. So our answer so far is that we have 1 day and then we also have 1 hour, and then we also have 0.6 of an hour. We need to take that 0.6 of an hour and convert that into minutes. So we take 0.6 hours and we multiply it by the unit fraction 60 minutes over 1 hour. Doing the multiplication, 0.6 times 60 over 1 is equal to 36 minutes. So our final answer is that the biker's cycling time is 1 day, 1 hour, and 36 minutes. All right, well, you made it to the end of our video. I'm Professor Diwa. Thank you for watching, and I'll see you in the next one.